let's look at another example. So now we have a circle. It's a smaller circle. I don't actually know what the radius is. I could figure it out if I wanted to. But the important part here is I know 1 point in the circle, 2 comma negative 1, and I'm asking for what is the equation for the tangent line at that point on this circle. And once again, that's all you really need to know. Oh, I've got a circle centered at the origin. I've got another point. Let's come up with the equation for the tangent line. So this time our point is 2 comma negative 1. All right, so I'm going to walk through these steps again. The first step is I need to get the slope of the radius through that point that connects the origin, the center of the circle, to that point. And that is just going to be our y-coordinate minus 0 over our x-coordinate minus 0. It's always change in y over change in x. And so we get negative 1/2. So that's the slope of our radius. Because the tangent line is perpendicular to the radius at that point, the slope of the tangent line equals just positive 2 over 1, so you can just write it as positive 2. And note as well here that as I'm writing this out to differentiate between my two slopes, I'm using subscripts where I'm writing m sub r for the radius and m sub t for the tangent, and that's just so I can keep straight which slope is for which line, and so I know which one to actually plug in. So this time I'm going to go ahead and plug straight into slope-intercept slope-intercept form. And once again, this is another way that you can come up with the equation for a line. If you know a point and a slope, you plug in your slope for m, you plug in your point for your x and y, solve for b to find your y-intercept, and then you'll have then you can write your equation. So I have negative 1 equals my slope of 2 times my x-coordinate, which in this case is also 2, plus b. So I multiply. Negative 1 equals 4 plus b. Solve for b. Negative 5 equals b. So now I know what my y-intercept is. It's negative 5. And so my equation in slope-intercept form is y equals 2, the slope of the tangent, x minus 5. Because our slope was a whole number, we didn't have any fractions this time, which is nice. But we could have gotten there as well using point-slope form. So let's look at what this looked like on the graph. And we'll see our equation, our radius, and our tangent line. And we can see that our tangent line does indeed have this y-intercept at negative 5. So that is one more example of how to find the equation for a tangent line of a circle.